Okay, back to business. So I was talking about um oh, internet don't start again. I was talking about UTP. There are terminators for all types of cable. Now, in UTP, I said the terminator is RJ45. You get hello?
So
Hello?
you can submit it yes. RJ45. Yeah, no, yeah.
Okay, so RJ45.
RJ11.
Yeah, RJ45. The terminator is RJ11, RJ45. As in terminator of TP is RJ45. And when you are terminated, you will have what we call cabling scheme. Cabling scheme, when you want to terminate, there are of two types. We have T568A and T568B. Now, if you're using T568A, is a kind of the way the cable is supposed to be terminated on the RJ45. Now, if you're using this material method, it means that you should take in this color first, stripe green. After stripe green, then green itself. Then all the other color follows. But the way to memorize is that just know that in TP cables, two-step cables, we have this green, this green and orange, green and orange, orange. We call them data cables.
Okay.
They are data cables. Why they are data, I call data cables, they are the one that carry the data. Other ones are we are reserved for PoE. They were actually reserved, but later on we will discover that they were used for PoE. Now, you see this color, this green, and you see the color, this one and this one. They are data cables. The same thing goes with this. So if you're using cabling scheme A, see the way you're supposed to start it. Green will start first. But if you're using B, orange will start. There are two data cables. Know that the first one is always the stripe. And in two of them, the last one are always brown colors. And in two of them, the center ones are always blue. So the only thing you interchange here, they are just data cables, green and orange. The blue is always on the center, and brown, the last one. Just know that the stripes do not come together. Like there's a stripe here, there's a solid here, stripe, solid, stripe, solid, stripe in two of them. So when you are terminating your cable, you must follow that way. Now, in these two, in these two, if you're using A, use A true. If you're using B, use B. It's not as though if you mix the two, they're going to be issue. There's not going to be issue, but there's this issue of uniformity. It's always good to make things uniform. So if you get to a particular place where in an enterprise where the installation, the cable installation, they use the A to terminate. Continue with A. If they use B to terminate, continue with B. It's professional. That's a best practice a best practice in the profession. Now, if you terminate with A, like if this end is A and the other end is A, or here is B and here is B. If here is B and here is B, or here is A and here is A as well. That type of cable is called straight through cable. Do you get what I just said? Hello?
Just be careful.
I said straight through cable. It's not written here. Straight, as in straight, straight, something that is straight. Straight,
Just be careful.
straight, straight, straight
Be
through.
careful.
They are called straight-through cables. Now, if the both ends are the same, either A and A or B and B, but if you have A here and have B here, it is called crossover cable. Crossover cable. Now, this is just the way I've thought about the color coding. I've thought about the two terminators, straight through cable and crossover cable. Now, when do you use straight through cables and when do you use crossover cables? Straight through and crossover. Now, I want to bring, this is straight through. I'll bring crossover. Now, I'll first of all start with straight through. Now, straight through cable is when you have one end A. Here is actually A. Okay, looking at this place, what do you have here? This is green. What is here?
I can't see anything.
Sorry?
I can't see your screen. I can't see what you're showing me.
My screen. You can't see my screen.
Yeah.
I'm sharing it. You're supposed to be seeing it.
I'm just seeing open step and cancel that faster, something like that.
Can you say that again? It's cracking. Your voice is cracking.
That's why I can only see like about this the tax bar now. I cannot see the screen you're sharing. Okay, it's not moving now.
Okay.
I can see it now.
Okay. Now, straight through, they actually use A here. Why is A? Because the first one is green, right? As I said before, the first one, if it is green, it is A. If it is orange, it is B. Starting cable. So C straight through cable. Straight through cables are used when you are connecting unlike devices. You see what I underlined? Unlike devices. When I mean unlike devices, like we are connecting computer to a switch, for instance, computer to a switch, or we are connecting switch to router, or when you are connecting something that is not the same. Like, okay, see it here. When you are connecting switch to router, or you are connecting hub to PC, or even PC to switch, is referred to as online devices. So these are the places that you use straight through cables. Like you can see here, this is a PC connecting to a switch. So when you are running such connections, you're supposed to use straight through. And when you run it, the way data is supposed to move is that when data is moving from here, from PC, transmitting, this is the first end. Of course, it's supposed to locate its other end. You understand? Do you understand? Hello?
I do.
Okay.
I can hear you. I do understand.
Yeah, so it's supposed to get to the other end. So when this guy is responding, when the switch is responding, switch will respond from here, and it will enter here and here. This diagram is very important. You expect that in your exams. Sometimes they used to ask this in exams. So you're supposed to know the numbers 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So however way they ask the question, maybe they'll be asking if it's passing through 1 and 2. It should receive through 1 and 2. Then transmit 3 and 6. So that is for straight through. Now, crossover. Where do we use crossover cables? We use crossover cables when we are connecting like devices. For instance, what we have all here. When you're connecting switch to switch, switch to hub, hub to hub, router to router, PC to router, and PC to PC, you use crossover. Crossover cable. Like now, we look at this place. It's finally here is what? Here is A. Why here is B? Can you see that? Hello, do you see that? Shit. Hello, 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 hello. Hello, 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 hello. Can you hear me? Okay. You cannot minimize when you are recording. Okay. You can see my screen. Can you see my
I
screen?
can only see Mata between. I can't see your sharing.
Hello, I'm coming, coming, coming. Hello, 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 hello. Hello, 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 hello. I want to share this screen.
Okay.
Yeah, you can see my screen now.
I
O-
can.
Okay, now I thought about straight through. Straight to use it to connect online devices. Why crossover? Use it to connect like devices, like as we have here, switch to switch, switch to hub, hub to hub, router to router, PC to router, and PC to PC. So these end users or end devices are called like devices. When you're connecting PC as we have here with another PC as we have here, so you're supposed to use crossover. How do I know it's crossover? Because this place is A. Can you see it? It starts with green. Why this says B? It starts with orange. Do you get? Hello?
Yeah.
Okay, so
I, yeah.
now, when this guy is communicating, it should transmit from here to here, but it's going to enter here and here. Receiving have to be here. You see now, when it is now, this guy is replying. He moved from here. That was why this guy is trying to locate the end. So you're going to locate here, and this guy locates here. So you're supposed to know how this thing works. Everything has to do with data cable. Data cables, orange and green. So you have to know that their movement when they are transmitting data. So that's for cable. So far, I've talked about what host is. I thought about what peripheral is. I thought about what network devices is. I thought about what media is, but I didn't come to wireless. Now in cabling, as I said here, like um is it supposed to be this? Okay, like cable, I said that in this cabling scheme, it's only data cables, green and orange, that uses data. Every other ones, they were reserved for PoE. Do you understand what I mean by PoE? PoE is a power over Ethernet. Power over, oh shit. Power over Ethernet. You get?
Yep.
So power over Ethernet is PoE. So this is Power over Ethernet, we call it PoE. Is a technology that um, allows data and power to pass through cables. For instance, our modern cameras, some of our cameras, you don't need to power them separately. Normally, you know that when you buy a printer, when you connect your network printer cable to whatever, either to the host or to network device. Okay, let's say when you're connecting your network, you're connecting your printer to your host, you connect with a cable and you still need to power the printer. If you don't power the printer, it will not work. You understand? The same thing goes with your PC. You have to power it. If it's your other things, you connect scanner, you have to power it. But there's a technology that allows a particular end device to get or to source its power straight from the same cable that carries the data. And such devices are called powered devices, PDs, powered devices. They make use of this technology, PoE. So when I connect, if I'm connecting, if this is my camera now, assume that this camera is connected to this. This camera now does not, I don't have another source of power to it. The power comes from here to the camera. So I don't have to power this camera separately. So if camera is using that kind of technology, I call that camera PD, power device. Now, or now if it is connected to a switch, for instance, and a switch that is powering it, or hub that is powering it, that hub is referred to as PSE, power source equipment. Power source equipment. I want you to go to internet to browse about PoE and read more about that. I'm not going to go much into that. So, where if this switch is a PoE switch, it's not all the switches that are PoE enabled. So when you're buying switch in the market, there are PoE switch and non-PoE switches. PoE switches are more costly in market because of what external thing they do. They give out power and also with data at the same time. So such switches are called power source equipment in terms of in PoE technology. While the ones receiving the power is PDs, powered devices. We have different standards in PoE. We have PoE, we have PoE plus, we have PoE plus plus. I want you to go and read up all those stuffs in internet. Now, the only thing I want to add to that is PoE plus. We have a technology called PoE plus and PoE plus plus. PoE plus as this. PoE plus is a PoE technology that some PDs use, whereby the switch, for instance, that is powering them. I need to get, for instance, the switch that is powering them. Coming. For instance, if this switch is PoE switch, this switch that is powering, possibly, maybe this is a camera, for instance. Maybe the PoE, the technology, PoE technology this switch is making use of is using 40, let's say 24 volts. Let me say 24 volts. Why this device is needs 48 volts or 50. And of course, you know that if I connect this with the cable, it will never power this. Do you get? Hello?
Yeah. I guess I got that.
So when if for instance his phone, you know these phones that we use in offices, as soon as you put the cable, it powers immediately. All those voice over IP phones, it powers immediately.
Yeah.
Now we have other things like alarm. We have which other thing that uses this alarm, cameras, and so many other things that uses that technology. Now, if the PD is 48 volts and the PoE switch is giving output of 24, it will never power that. So in such case, you buy, or if the device did not come with a gadget they call PoE, some people call it PoE adapter. PoE adapter, that is adapter. So it comes with something called PoE adapter. Some people call it PoE converter and all of that. So what this guy does is that you know that you know about your laptop, that you see the your laptop charger. Hello?
Yeah.
Laptop charger looks like something like this. Then this one comes, this one you
Yes.
connect a power this thing to the camera. This one now, this end goes to your PC. Now the adapter looks the same way
Mm.
like your laptop adapter, but it has Ethernet end here and another Ethernet end here. So now it might not be like something like 50 volts, for instance. So now this particular end is always written. Here will be written something like PoE. Here will be written PoE. This one will be written something else. Maybe this one might be written LAN, for instance. What you now do is that the PoE side, you connect it to that your camera or your phone, while the LAN goes to the switch. Do you understand? Hello?
Mm-hmm.
Hello? So,
I can
now,
hear you.
okay. Now, normally switch is supposed to connect directly to this, but because it cannot power this, and I'm bringing adapter, so the switch will now go through this point as LAN. This guy will now receive the data and takes the data to PoE switch and add more power to it, so that this guy will now get it. In a case whereby switch cannot power that device, so that technology is referred to as PoE plus. Do you understand? Hello? Hello?
Yeah.
Okay, that technology is called PoE plus. Now that's for PoE, but there is more to PoE. I want you to go and read up PoEs. Just go to internet, type PoE. If you have more questions or any confusion about PoE, just let me know so I can put you through on that. I don't want to go more into that. Now, I've talked about cables. I will come back to wireless later on. Then devices, network devices. What did I say about network devices? Okay, examples of network devices. I said we have what? Hub, we have switch, we have router. Sure? Hello?
Yeah.
That's what I said about that. Now, I will explain
Yeah.
because
Yeah. Yeah.
I'll be taking them one after the other and be explaining. Now, this is hub. Hub, believe me, if you go to market, you won't see a hub in market. In Nigeria market, I know that Nigeria, sorry to say this, is always the last bus stop in terms of technology. Africa as a environment or as a society is always the last bus stop, although South Africa is trying anyway. But it's when the technology has finished, exhausted there, you now come and land here. Now, even as the fact that hub, they still teach, Cisco still talk about hub in their syllabus. You can't get hub in Nigerian market because of the way it behaves. Nobody can see, you can't see hub anywhere. People don't use hub. Although when I finish explaining things about hub, switches, and router, you don't see the reasons why no sensible human being will go to the market and demand to buy hub. Now, hub is a network device. I will explain how it works, the differences on how it works. Now, the way hub works, when you look at this diagram, it's covered that if this source, when I mean source and destination, source it means where data is coming from. Destination is where it's going to. Now, when you in your network, when you connect your network using hub as a network device or nexus, when a source sends message to that's supposed to go to destination, when it gets to hub broadcasts the message to everybody. This guy will receive the message, this guy will receive the message, this guy will receive the message, this one, everybody connected to the hub will receive the message. What I mean is that hub will going to broadcast the message through all the active ports connected to it, except where the message is coming from. So the message will not return back to the sender, but every other active port, when I mean active port, the port that are connected, will receive that message. So when they receive it, they will ignore it. You see that they ignored it. This one ignored, everybody ignored the message. It's only the person that is destined for that message will accept it. You understand? You understand?
Yeah.
Okay. Now, one
Yeah.
more thing about hub you need to know also is that hub does not have a memory. We have hub, we have switch, we have router. Now, these two has memory. And their memory, they have RAM, and another one they call MV. Now they have two memory, they have RAM and they have NVRAM. RAM is normal RAM you know about. RAM is read access memory. It's just something that keeps the configuration, or how will I put it? It's just what keeps the process of your system. As far as the system is still on, it is volatile. Like if you are typing something on your system or your computer and you don't save it, maybe on your desktop without a UPS, and light goes off. If you don't save that work is done, is gone. Do you get? Because you didn't save it. So actually, when you are typing something, maybe on a notepad, that that thing that you are typing is saved on the RAM. So if light goes off, that thing wipes out entirely. But when you want to retrieve that file, you save it. And when you save any work, the work is saved where? Inside your hard disks. Excuse me. It's saved inside the hard disk. So the same way, routers and switches, they have RAM and NVRAM. NVRAM is called non-volatile RAM. So NVRAM can be likened to be the hard disks of RAM or switch. So when you are configuring anything on a switch on the RAM or the router, that configuration stays on the RAM. But when you save your configuration, it now go and save inside NVRAM. That's the hard disk of the network device. But hub does not have memory at all. That is why anything that goes inside of it is now broadcasted. Now, another thing too is that if this guy source is sending message to this guy, and for instance, this guy, let me call this one, is sending message to two, and by mistake, this guy, when the message entered the hub, or the same time, message from this guy H2 entered the hub at the same time with message coming from here, enter this hub. So when they enter the hub at the same time, there will be something we call collision. And when the collision occurs, the message becomes corrupt. We call it garbled. The message becomes garbled or corrupt. That means it cannot be used for anything. Now, when the message is still corrupt, this guy, Hub, will still forward the message to everybody that are supposed to receive it. And the message is useless, it's corrupt message, it still forwards it. That's another characteristics of Hub. Do you understand?
Yeah.
Hello? Okay. Now, coming to switch. Switch, where is my switch? Now, coming to switch, it's not like that in switch. As I said before, that I need to, switch has memory. It has RAM and NVRAM. So inside the NVRAM, switch has a table called ARP table. ARP table. ARP table has MAC table inside of it, MAC address table inside of it. This is not the complete ARP table. ARP table has MAC address table and other things, even IP
Okay.
address. Now, this ARP table, let me be working with MAC address as we have. This, okay, let me add some things to it so it will help you to explain this port, MAC address, and also IP address. Let me say put this one as 192.168.1 dot this one is 4. Let's say 4. Now, in the ARP table, it has the port number, MAC address, and the IP address. So this port, maybe this port that this guy is going 4. Okay, 4 is connected to fast Ethernet 0/4. That's the meaning of this. Fast Ethernet, that's the port on the switch. Fast Ethernet 0/4, and the MAC address of this guy is this, is this, and the IP address is this. Everything dot 4. So the same way it has for every other ones. Now, this ARP table, um, sorry, this ARP table is always empty at the first installation um, of the switch. At the first installation, it's always empty. Now, switch takes time to update the ARP table. How does switch do that? The way switch does that is when any host wants to send message. For instance, this guy wants to send message to, okay, let's say this guy H1 wants to send message to H4. It will now ask who is 4. But ordinarily, it's supposed to, this guy will have, hosts also have their own ARP table as well. But for it to send message to another person, it needs to fill the frame. I'll talk about what frame is. Okay, at your level, let's put it this way. It will ask of who is H4. So for H4, when I say, here I am. Now, when it's asking who is H4, you're going to ask the switch, who is H4? So when you ask the switch will be like, oh, I don't have any memory of 4, because in ARP table, everything here will be blank. The whole table, sorry, the whole table will be blank. So when this guy is asking who is C4, which H4, switch should be like, I don't know who H4 is, but why this guy is asking who is H4, this guy is introducing itself to the switch. So what switch would secretly do is that it will now be like, oh, H1, you are connected to my F first Ethernet 0/1, and your MAC address is this, and your IP address maybe 1.1, for instance. It will secretly save this guy's information and now ask who is H4. It will now broadcast the message. It will send the message to this guy, send message to this guy, 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 to this. So are you there? Hello.
Yes.
Okay. So we have unicast, we have multicast, and we have broadcast. Broadcast. So these are different message patterns. Different message patterns. We have unicast and now uni. Anytime you hear uni, it has to be one. So when unicast is when, where's my cursor? When you are sending H1 is sending message to H2, is unicast 1-to-1, or H1 is sending to H7 or H6 or something 1-to-1. Like just as I'm talking to you now, is unicast. But multicast is when you are talking to a group of persons. Like now, how many computers are here? There are about 8 of them. 1, 2, 3, 4, 5 to 8. Now, if H1 decide to talk to only H2 and H3, or H2, H3, H4, only in the group, is referred to as multicast. But broadcast, just as the name broadcast, everybody. You know that we used to hear that TV broadcast, radio broadcast is for everybody. As far as you tune, you can get it. Unlike calls, if I'm calling you on the phone, it's unicast, 1-to-1. If I'm doing conference call, I think it's that way broadcast as well. So, but just know different between unicast, multicast, and broadcast. Uni 1-to-1, multicast is when you're talking to some group. When you have so many people, you are talking to some group. Then broadcast is when you're talking to everybody. Now, back to what I was saying before. And I said that when H1, normally I said before that ARP table, ARP means, I don't used to know the acronym, but ARP, I think address resolution protocol. When it is blank, as I said before, the way switch fills the ARP table is when a host wants to is asking about another host, like when H1 is asking about H4. It will introduce itself in the message when it's asking switch, who is H1, H4. In that message, he himself will introduce himself. So this switch now will secretly write the information about H1 in its memory, in its ARP table. It now feel H1 is connected to my F fast Ethernet 0/1, and the MAC address of H1 is this. An IP address is whatever, 192.168.1.1 possibly. So it will save it. Now, H1 know that there's an IP address called 192.168.1.4, but it does not know the MAC address. So it's asking who has this IP address. So everybody will receive that message when the switch will broadcast it. You understand what I mean by broadcast now?
Yes.
Now, broadcasting in switch is called flooding. Flooding. Flood, as in flooding. Don't mind my writing, is system. Flooding. So you can when you're talking to an IT person, when you say flooding in switch, the person will understand that it's broadcast. Broadcasts that happen in switch is called a flooding. So when H1 is asking who is H4, switch will now flood that information to everybody. So they will not be like, oh, I'm the audio, I'm not 4, I'm not 4, I'm not 4. 4 will not be like, okay, I am 4. It now respond to the switch. Now respond to the switch. I am 4. When this guy is responding to the switch will not secretly write the information about H4. That H4 is connected to my fast Ethernet 0/4, and the MAC address is this, and the IP address is this. That is the way switch takes time to fill the ARP table. Now, if switch know about H4, now if H5 is asking who is H4. Switch will secretly as well fill the information about 5, but since it has knowledge about 4 here already, it will not flood that message. You understand? It will just tell H5 that information about H4. So it only floods messages when it does not have information about that in its ARP table. You understand?
Yeah.
Okay. Now, there's one more thing you need to know about ARP table. ARP table, hosts, switches, okay, host network devices have their ARP tables. So when any host wants to send message to another host, it fills the frame. I will talk about frame. How does it fill the frame? It picks information from the ARP table to fill the frame and send. So they need to fill up their own ARP table. That's why they're asking the switch. So that is how switch fills its ARP table. And one more thing too, there's something we call aging time. Aging time in switch. Aging time in switch is always, our default is always 300 seconds. This aging time in switch is the duration of the memory of a particular device. For instance, now, in the ARP table, for instance, if switch records information about H1 in this ARP table, it will now set a timer that will last for 300 seconds for F for H1. So if nobody communicates to H1 and H1 did not communicate with anybody within that stipulated time, the switch will not delete the information about H1. Do you understand?
Yep.
Yeah. So that's what we call aging time. As soon as it receives information about a particular host and fills in the ARP table, it will now set a timer. And the default is 300 seconds. You can actually change it anyway. You can actually reset it, change it to any particular time of your choice. So if that device did not communicate and nobody communicated to it, it automatically wipe out the memory of that device in this ARP table. Now, for instance, if you now add a device, maybe this is the network, the ARP table, the whole ARP table here is already filled up. And you now brought a new device. Call that device H10, for instance. H10 will just stay. If nobody communicates with H10, H10 will just automatically introduce itself to the switch. Hosts are made that way. So switch will now fill its ARP table. So this is how switch fills ARP table. Now, one more thing you need to know is that as soon as the ARP table they are filled up, when a message like let's say H3 is going to this place, destination, source to destination, switch will send, if this guy is sending message, the message will go straight to the destination because switch has information about this guy in this ARP table. So it will not broadcast the message to everybody, unlike hub that does not have memory. You understand? So that is how, that is why switch can actually send message to individuals. If H4 is sending message to H6, it will just go straight to the H6. As far as the ARP table is filled up, the only time switch will broadcast or flood is when ARP table is empty or the information about that particular destination is not in switch ARP table. That's number one. Another characteristic you need to know about switch is that switch, what else do I want to say? Now, collision, in terms of collision, if H1 Where's my cursor? Okay. If H1 is sending message to, say, is sending message to H4, and H5, for instance, is sending message to H7, and peradventure, the two messages now enter the switch at the same time. The message from H1 and H5 enter the switch at the same time. There will not be any collision, unlike hub. Why wouldn't there be collision? Because switch has something we call, we'll talk about that one later, we call something we call VLAN. It has VLAN inside of it. VLAN 1. So all the ports on the switch, they are all connected in a virtual LAN, like in a small network inside. You know, virtual is something that is not physical. You cannot actually lay hand on it, but it actually exists. So it has a kind of its own network that can actually interconnect. It's somehow call it a micro segmentation. So they have different parts. What I mean by micro segmentation is that they have different parts. H1 have a path to follow. This one has its own path. They have all different paths. So H5 can actually communicate with H7 freely. H1 can communicate with H10 freely. Even if the message jam enter the switch at the same time, they have different paths they follow. The only time collision can occur in switch is at the interface. Like for instance, H3 is sending message to H5. And H5 wants to send message to, no, let me put it this way. H3 wants to send message to H5. And H5 wants to send message to H7. Now, when the message H5 is coming to the switch, it enter the switch and now start to locate H5. And at the same time, H5 is sending message to H7. And the message they now jam here on interface. That is only time collision can occur in a switch. Do you understand?
Yeah.
So collision only occur on the interfaces of the switch. Why on the hub? Collision occurs on the hub. As far as it doesn't matter, even if the hub has 24 ports, as far as any two messages enter the hub at the same time from anywhere, there will be a collision. Unlike that of switch. Switch, only time collision can occur is on the interface. So that is why we say there is something we call collision domain. Domain is actually area where something occurs. Domain is just an area, a small area, as English word. So collision domain is where collision can actually occur. So in hub has only one collision domain. In hub, we have only one collision domain. Collision domain. Don't mind my writing. Only one collision domain. Because collision can only occur here. There's no other way. There's no other place. So the number of collision domain in hub is only one, no matter the number of interfaces or active interfaces is connected to. Why? Where's my cursor? But in switch, we have the number of collision domain increases according to the um, number of interfaces it has. Like this switch now, if someone asks you how many collision domain does this switch has, it is 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 is 10. I miscounted. It's 10 of them, 10 interfaces. So the number of collision domain in this switch is 10. If it's connected to 11 like that, because it's only on the interfaces that the collision can actually occur. Only on the interfaces that collision can actually occur. You understand? So these are the number of collision domains. So that is that for hub and switches. If I can remember more thing, I will talk about that. Now, looking at this place now, this switch, too. If I a- if someone asks you how many collision domain does this switch 2 has, how many of them? How many collision domain does it have?
I, Nine.
Sorry? It's a
It has
9.
nine collision domains.
Yes,
Nine,
exactly.
yeah.
Because there are 9 interfaces. That is 1, 2, 3, 4, and all of that. 9 interfaces. Why this hub? How many collision domain does it have?
One, two, three, four, five,
That's hub.
nine.
Oh. That's hub.
Yeah, nine.
No, hub is one collision domain. Collision can only occur.
Okay, okay, tell me only one collision domain because I'm a bit I got confused because I'm seeing nine devices connected to the hub. So which means the devices are only connected only on one port.
Yes, no, it's not one port. It's not connected to one port. It's because of the way hub behaves. That is why we now say collision
Oh,
domain. Yeah, because of the way it behaves. Because now, if this source, if this guy,
it does not it does not have memory, so it does not split the information.
exactly, it does not
Only
split. Yeah,
process the information.
yeah,
Yeah.
it does not have memory. It does not split information to individual or to the
Yeah.
destination accordingly. And when
Yeah.
two messages enter, when two messages, like something coming from here and something coming from here, enter the hub, there will be collision. And it doesn't matter the interface they came from. So that is why we now say hub has only one collision domain, no matter the number of interfaces, active interfaces connected to it. So now that's for that collision. If I remember more things, I will let you know. Now, when you look at this diagram I have there, if this source H3 is sending message to this destination, how would it go? If it will
What is
enter the
it?
hub, and hub will broadcast the message to every
Can
active
to
port.
all the devices connected. Yeah.
Yes. So it means that 8, 7, 6, 5, 4, 2, and 1 will receive the message. Even this switch will receive the message. And switch will now send it to this guy. This guy, if this guy has ARP table field, it will send it straight to this guy. You understand? The only time it will broadcast is when it doesn't have information about this guy. You
Oh, okay.
understand? So,
Yes.
um, I need to ask you some questions now. If the same way, okay, now if H5 is sending message to H8, how will the message go?
If H5 is sending message to H8,
Yeah,
okay, on the hub, if it sends to H8, it's going to. I mean, if it sends the message, the hub will broadcast it to every network, to
yeah,
every connected.
active port.
Including switch,
Yeah,
including the switch one. Then the switch one will now send the message to switch two, and then switch two will now, because it has ARP, then it will now.
sorry. I didn't. Now, see, my question is H5 is sending message to this particular H8. Maybe I've not explained that. Let me explain it before I ask you. Now, if he's sending
Okay.
H5 is sending message to H8, message you get of hub. Of course, hub will behave the way it normally behaves. It will now broadcast the message to all the active ports connected to it, apart from where the message is coming from, apart from here. So it means that switch is going to receive it. 1, 2, 3, 4, 6, 7, 8 will receive the message. But they will all ignore the message because it doesn't pertain to them. Even switch will ignore it. So it will just go to,
Oh,
yeah,
to
switch
go to
will ignore the message as
H8,
well. So
H8
it's,
will now process the message.
yes, so it's only 8 will now respond. You understand? So let me now figure out another question I can ask you. Now, what of if these 3 If this 3 is sending message to 7, how would the message go?
Okay, if you send a message to 7,
Yeah.
because it's on switch,
Okay,
you
switch
send
2.
to switch. So switch will not broadcast it.
Yeah.
The switch 2 will not broadcast every network. If you send it straight to switch 1, switch
If
1 will
it
now send
wait, if it has
to
the ARP table filled up, oh,
AI
yeah.
stuff. Yeah.
Okay.
So, but I'm presuming it has because we are talking about switch based on
Yeah.
what you explained.
Yeah.
So if you don't go straight to
I lost your connection. Hey, connection lost.
describe it, and then why only
Sorry, I lost your connection. Just say it again. I lost connection. Okay, can you say that again?
okay,
Yeah.
um H3 if you send the message to switch. So if
Okay.
switch has ARP table, it will actually it will not broadcast it. It will only send it straight to switch
Okay.
one,
Yeah.
which also has ARP, which will now send it to the hub.
Yeah.
Then the hub will now broadcast it,
Of
and
course.
then while the rest of the network ignores it, I mean the rest of the devices will ignore it. H7 will now receive the message and then process.
Okay. Yeah. That's just it. So if you have understanding of how hub works and switch works, you can actually interpret however message, wherever it's coming from and how it's supposed to go. You understand? So
Yes.
I will assume that you have explained things you need to know about switches and hub. The domain, this guy, hub always have one collision domain. Switch has collision domain according to the number of connected interfaces. Now, looking at this diagram, if you are asked how many collision domain in total, what we have here is somehow uh, skeptical
Okay.
to calculate. Now, if you are asked to calculate the whole number of collision domain here, the way you're supposed to calculate it is one. You calculate 1, 2, 3, 4, 5 till 8, right? This is number one,
Yes.
2, 2, 3 to 8. That's the 8. Uh-huh.
Mm-hmm.
This one is 9 and is sharing it with 2.
Yes.
Switch 1 and switch 2 are sharing this as one collision domain. So this one, everything in here is 1.
Wow.
Everything is here 1. So we have how many collision domain? 8 plus
Yes.
9 plus 10. Yes. We have total 10 collision domains in this network as it is. So just take your time and read up as well. If I didn't um, put other things too, maybe you can read it up. And again, maybe I will talk about that one later on. No, I like teaching. We'll talk about that on the phone, not here. Because if there is, okay, later we'll deal with that. That is personal thing to talk about. So that's that for switch and hub. Then, is there any other thing you need to talk about? Okay, I wanted to ask you a question, but I've already asked you that question. Okay, looking at this particular place now. Now, if H4, let me ask, if H4 is sending message to H8 and switch 1 and switch 2, their ARP table, they are blank. How will the message go? Of course, H4
Okay.
wants to know about H8 and switch 1 and switch 2 have blank ARP table. How is the message going to go?
If you definitely if you send message to the hub will broadcast it
Uh-huh.
to all the domains,
Okay.
to all the interfaces. Then switch one will pick it up and also broadcast it to all the interfaces. And then
Okay.
switch two will pick it up and broadcast to all the interfaces. While
One
only the H
will,
while only H8
will
on
respond.
switch one, while the rest of the interfaces will ignore it.
Yeah. So I think you've understood this. If you can answer this question, that means you've understood that. So I don't think I can figure out another question to ask, but if you've understood that in however way, you can actually answer anyone. So if it has ARPT will filled up, it will broadcast. It sends straight away and all of that. So that's that for switch. Now I'll be talking about router because you know that I am still talking about basic computer components. I've explained hosts, I've explained peripheral, I've explained media, but I've never thought about wireless. Then I am still explaining network devices. Network devices, I say we have hub, switches, and routers. So let's talk about router. So router, supposed to use this. Okay, now router. We just know one thing that CCNA that you are uh, taking the class for is CCNA routing and switching. So we are going to be talking about switches and routers until we finish our course. So it's not as though I'm
I
done.
want to ask you a question.
Okay.
I want to ask you. Is
Yeah.
this thing only for only route and switching?
Yeah.
Is that the only thing that is possible?
Is that the only thing that is?
Is that the only topic, maybe the only course on CCN, only routers and switches? The
Yes.
other
In Cisco have
yeah.
different. I put some hierarchy of certification. We have CCNA, we have CCNP, we have CCIE. We even have DevNet. We have other ones, but these are the major ones in hierarchy. CCNA is the foundational one, and it is all about routing and switching. We call it CCNA routing and switching. It's all about routing and switching. That is CCNA. It is routing and switching. We now have CCNP, Cisco Certified Network Professional. In this case, you now specialize. You want to go into wireless, you want to go into security, you want to go into collaboration, you want to go into uh, voice, you want to go into, there are many of them. This is where you specialize. But this one is foundation. So by the time you finish this, learn this one, if you have data, this one you have data, something like data center, enterprise, many of them. So, but this one is foundational one. It's about routing and switching. In this case, you're not specialized. Okay, I like to deal with things about wireless or security or collaboration or voice, data center, and many more. After that, there is CCIE. CCIE, that is internet experts. The same thing here is specialized as well. Wireless, security, blah, 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 specialized here as well. But current syllabus in Cisco now, I think you can actually jump CCN and go and write CCMP. Unlike before.
Eh,
Yes, unlike before, you must write CCNA before CCMP. But now, you can go straight and write CCMP without writing CCNA. They changed the syllabus. And not only that, they changed so many things too. They brought in automation, programmability, and automation. We are going to still talk about that. Automation and programmability, where we use Python and other programming languages to configure network devices. We are going to deal with that later on. So that's that. Where were we before? So back to what we've been doing before, router.
okay.
Now, why I even brought up this issue was that you shouldn't just assume that, I'm done teaching switches. I'll see everything we'll be talking about switches and routers, switches and routers, switches and routers until we finish. But I'm just trying, we are taking it bit by bit, so that we're able to understand. As we are climbing, we're getting something tougher and all of that. So back to router. Router is actually used it's used for so many things, but at your level, I just say that it is used to segregate network. Segregating a network, you understand how you segregate network by the way it functions. Now, I'll need to come back here to talk about this. Now, let me remind you here. If this switch do a broadcast, this guy will receive it. This guy will receive it. If you have another switch 3 will receive it, right? You understand?
Yes.
So, but in router, this is router. This is the way we used to represent router. This is switch. This is symbol for switch. This is symbol for switch. If there is a broadcast here, maybe this guy is asking who is so and so. If broadcast occurs here, it will still enter here, right? But when it gets to this place, router will ignore it. Router does not extend broadcast to another interface. So this one, if there's a broadcast here, if they have their other switches, fine. They all receive the broadcast. They all receive the broadcast.
I didn't just get what you said about the router. I said this is router when if it broadcasts, when it gets there, the router will ignore it. I didn't really get that very well.
Okay. Now, if there's a broadcast here now, maybe now this guy is asking about someone here. He's asking who is someone here, or even asking who is someone here, for instance. When it gets to the switch, the message you enter here, enter here, enter here, enter here, even go here. So everybody here will receive it. 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 When it gets to this place, on this interface on the router stops it there. Router will not allow it to pass, as in to pass to enter these people. You understand?
Yes.
The same thing goes with this. This one can have other switches or other hubs. The brokers will get to their switches and a hub, but as soon as it gets to this place on the router will never allow it to pass. So router ignores broadcast messages. Or let me put it this, it does not extend it. That is why we call this place a broadcast domain here. If you can hear me, say yes. I know you can't hear me. When you can hear me, say yeah. You can hear me now, right? Hello? Hello?
I can hear.
Okay, yeah, we are back on network. So, network is back again. You can hear me now. Hello, can you hear me now? Can you hear me now? Your online have been cut off too. Hello? Hello?
I can hear you. I can hear you.
Okay, fine. Now, I want to say something before. So because of that, we call this place a broadcast domain, a broadcast domain. So broadcast can actually occur here and here independently because of what router will do here and what router will do here. So this one broadcast domain, this is the second broadcast domain. So router has multiple broadcast domain according to the active ports on it. So if you ask how many broadcast domains
Routers are multiple words.
Can have multiple broadcast domains.
Okay, that's multiple broadcast
domains. According to the active, when I mean active ports, as in ports that are connected to it. Like now, this router can have up to. I'm coming. This is example of router. This is example of switch. This switch is about 24 ports, and it has a Giga Ethernet port. Now, when you use these ports, these two, when you are connecting to another network device, we are connecting to another network
Okay.
device. You know that where we are in gateway, I was in gateway before. You know that here, if you connect to internet from here, everybody here always pass through this place to go to internet. Everybody here, they can be 60 something, 64 or 100. They will all pass through this place to go to internet. So that is why here, here, and here, the size of what they can carry is bigger. Just as you can have a pipe here and have a tank here and have another tank here. You want to fill, and you have small pipe here entering, putting water inside this place. So many pipes. I have so many pipes putting water here. And you want to channel this water coming here to this particular one. It is not wise to use the same size of pipe. Because if you use it, this four will fill this thing. You know, this one will be overflowing. You get? So for you to connect these two tanks together, use a bigger pipe. So this pipe, what are we passing through here? So this pipe is bigger than this small one. So even if these ones are 50, as you are pouring here, it will balance up the one transferring to this particular one. You understand? I'm just using water as an example. Now, in the same case with this particular network, these interfaces are always fast Ethernet. Fast Ethernet, their speed, the interface, the speed they can tolerate is 10 to 100. 10 to 100 Mbps. Mbps. Why? This is for fast Ethernet. Fast Ethernet. But we have just a Giga Ethernet. Giga Ethernet can take 1,000 and above.
1,000 megapixel per second.
Yeah, 1,000 above. And the one, so most of the places that you use Giga Ethernet is when you're connecting, when you know that where you are connecting, there is much traffic there. For instance, I have a server here. You know that if so many people are going to the server, so there'll be traffic here. There'll be much traffic here. Just like in the road, like Lagos Road now, for instance, the larger the road, the more accommodative it will become. But if it is tinier, it will now be causing congestion. But if it's large, people will be able to speed up easily. The same thing with this. You know that so many people are going to the server. So you need to make this interface big enough. You don't make it the same size as these ones. So if these ones are fast Ethernet, fast Ethernet, fast Ethernet, you shouldn't connect fast Ethernet to server. You shouldn't connect fast Ethernet to router or to another network device. Or if I have another switch, you now connect fast Ethernet to another switch. It doesn't make sense. It can still work, but it will cause congestion. So that is why there is a provision for Giga Ethernet. So this place, you use it for Giga Ethernet when you're connecting to another network device or server. These places are Giga Ethernet, Giga Ethernet. Why these ones are fast Ethernet? You understand? And most routers here, most routers are Giga Ethernet. Most routers are Giga Ethernet. Don't mind this place. This is a switching port. It functions as a switch. But this is a routing port.
Okay. Okay, routing and switching.
Yeah. So this example of router, this example of switch in real life. So I understand the Giga and fast Ethernet stuff. So back to what I was dealing with before. So now I said we have how many brokers domain here? There are about 2. Brokers 1 and brokers 2. So brokers can occur here independently. Why brokers can also occur here independently? If I have another one here, it's going to be, if here is switch, you have broadcast 3. You understand? So it's according to the number of
Okay.
active ports. But unlike these ones, broadcast domain is only one, no matter the number of switches and hub, whatever. Because if there's a broadcast here, it will extend here, it will extend, it will extend. So number of domain places broadcast can occur is just one. You understand?
Mm.
So here, no matter the number of switches, if there are 50, it's only one broadcast domain. Why in router is according to the number of connected um, active ports. That is why, as an IT or a network administrator, when you look at this network, when you look at this topology, I'll explain what topology is. Kind of this setting, let me put it that way. When you look at this setting, you just know that you have two broadcast domain, and because of broadcast domain, you use broadcast domain to equate network, local network. So when I look at this place now, and a network engineer will know that this place has two local networks because of the broadcast domain. So this is local network 1, local network 2. Do you understand? Because of their, if I add another switch here, I have 3 local networks. Do you understand?
Yeah.
So you need to know this basic thing. Collision domain, broadcast domain, different between hubs, switches, routers. But you still need to read up, because I may not have explained everything, but these are the basic things you need to understand. When you are reading your materials, you have to understand. Like this one, I may not have said things all here. Although I don't think we've gotten to this level where I start. I don't know what they explain here, but I just know the diagram. That was why I picked these things. I don't know what they're talking about here, but it's just the diagram that me I'm concerned of. I'll talk about this when we start dealing with IP addresses. So that's for that. So back to where I was before when I was talking about. So I've dealt with hosts, I've dealt with this, I've dealt with that, and I've dealt with this, but I've not dealt with wireless. I want to talk about this into the know that I've talked about. I finished dealing with this topic. This topic is topic today. Sorry, I didn't give you topic. Topic is basic. This is topic here. Basic. The topic is basic network components, and I said there are 4 of them. So these are the things I explained today. So it's remaining wireless. When I finish wireless, you can call it a day for today. If you have strength to continue, where I will continue. So why are you laughing? So
You actually,
sorry.
we're actually crashing it. So
Okay.
we're actually
So,
crashing it. Yeah.
but you still have a lot of things to read up. Oh, I may not have said a lot of things, so, but in the material you read up things. So wireless.
I mean,
Sorry.
hours.
My one is just to finish. We can determine that. My one is to finish. I am kind of somehow busy. I'm just doing this thing as a part.
No,
As you,
told
you,
it's
you mean
hours.
hours per class, Abi? You mean number of
Yeah,
hours?
yeah, it's very close at the hour.
Yeah.
I was saying 60 hours.
We can negotiate that. We can see how we can do that.
The same thing when is the exam coming up?
Exam, you can take exam anytime you want. If you want to take it today, it's just for you to book your time. You go and take it. You go to any Pearson VUE. They call them Pearson, people that have license to take exams. They call them Pearson.
Okay, definitely.
Our license, we are here to renew our license. But there are many of them. If you go to Cisco website, search for Pearson VUE. They will not ask you country, Nigeria, state, if you're in Lagos, you click Lagos. We're in Lagos. If you're in VI, you Sulele, in whatever. You have different centers.
It's only in there's only CCIA, CCN, and CCMC that you can write in Nigeria.
Only what?
Only CCN and CCMC can write in Nigeria. So
Yes, CCIE, you have to travel abroad to go and write it. I think you write it in United States, India, Dubai, and some other countries. But you have to travel. Definitely, CCIE, you have to travel out to go and write it. So that's that. Although we talk about the timing and all of that, it will help. So that we now know whether that, if we are in Nigeria, we can't tell when light will come. And this light I'm using right now is not really my own. So I'm tapping from a neighbor. We made some agreements and all of that. So that's just that. Then back to wireless. No, I'm supposed to, as soon as I'm done with
I don't
wireless.
think it's very well.
Okay. Hello? Hello? Hello, network just broke. Can you say that? When you're talking, you put your
I can hear
mouthpiece. Okay, I can. I can hear you too. Just put your mouthpiece on your mouth so that I can hear you clearly. Sometimes it breaks and comes and goes. You are saying something before. Hello?
I said that they run
Hello?
generator to start it.
Hello?
Hello.
I can hear you now. You wanted to say something before. Okay, maybe we'll continue. If you can hear me, just say hi if you can hear me. Ouch.
Welcome.
Okay, we are back, Abby. Network is back.
I can hear you. I can hear you. But
Yeah.
so I have a question in your network.
Okay. Now, let's talk about wireless. I will not go so deep. I'm not going to go too deep in wireless, but wireless is big. But when you read wireless, you'll be able to understand. I just want to show you some basic things you need to know in wireless. Um, Normally, wireless, as I say, is a medium. It's a medium that you use, one of the media. If you don't want to use cable, as we talked about before, you use wireless. And we have different wireless technologies we use. Ordinary wireless, as you can see on the screen, we have different wavelengths and their respective frequencies and all of that. The visible light we are using to see is within this range, and other ones and the rest of it. But the wireless frequency that we use for networking is radio frequency. Radio frequency is of this range. This one is for phone. This one is for wireless, like your Bluetooth, infrared. Nobody is talking about infrared anymore. So infrared, Bluetooth, and your microwave. This is the frequency they use. I believe so. Microwave supposed to. I don't know much about that, but these are frequencies that we use, wireless technology frequency that we use, and they are free anywhere in the world, I guess so. If you use any of these frequencies anywhere in the world, you will be prosecuted. Like, for instance,
Which
I can
one?
even, sorry, I said
Which
if
one?
you, these are the free frequencies you can use, these ones. If you use anything outside of this in any part of the world, you will be prosecuted. It's a crime to use any of these frequencies. Any of these frequencies outside of this frequency will be prosecuted. Because these ones are already reserved for our wireless technology, connectivity, Bluetooth, like when you are transferring Bluetooth to your phone or using Zenda and all of that, or even infrared. When you're designing electronics that is going to use wireless technology, this is the range of frequencies they should use. Or every other frequency is for sale. Like now, if you want to open your own radio station or TV station, you need to go and buy frequency. If you transmit in any of these, any frequency outside this range, you will be arrested. So, anywhere in the world, sir, that is that. And I said that we now use, okay, that's where we are. These are what we use for our radios and all of that. I never knew that I'm going to talk about wireless today, so I didn't bring out uh, what I may use. So, but uh, wireless LAN. Now, let me be opening the one by one. Sorry, I need to open all of them so that I know what and what I am supposed to talk about. Okay, wireless pictures. If I don't see what I'm looking for, I'll just explain to you things you're supposed to know. I didn't prepare for this wireless anywhere. Yeah,
Hello, can you hear me?
yeah,
If
sure.
you didn't prepare wireless, if you didn't prepare for wireless, you can maybe you can
No, no,
stop
no, no, no,
here.
no, no, no. It's not as though I'm not prepared. What I'm saying is that I, just as
Prepare
I
the
always
slide.
pick, know where to pick and where not to pick.
You know,
Where
you're
pick,
there.
huh? Yeah,
You
I'm
did
not
that.
going to. It's not going to take just like 10 minutes or something, and we'll be done. 10 minutes or something, will be done. Wireless. Now, just know that wireless, we have benefits of using wireless and have its own limitation. Unlike cables, we have when you're setting up wireless, it is very easy to move things around, especially where there is no particular things that are stable. You can just use wireless, and you can actually change things up. It's flexible, it's scalable. You can increase more users instead of cables that you need to bring cables again and all that. In wireless, anybody can come in and go out and all of that, and it's less costly. It's easy to set up, and it's good for in a harsh environment whereby you can't, maybe a place whereby you don't need to lay cables and disturb yourself, or some place where you cannot lay cables, you use wireless. So that is the major reasons why we use wireless. Then um, we have its own limitations as well. Like wireless can easily be interfered. You can jam it. You can design another frequency that can jam it so that people are having issues with getting signals. And also, it is easier to hack. Like people that likes hacking, you can easily hack wireless, unlike cable. It's very easy to hack wireless. Now, in wireless, we have, I'll come back to this. Where are all those? Was that all things that okay for sale? I thought about this limitation of it. Now, then we have different types of wireless networks. It starts from small and to a point where you can enlarge it. If you are doing Bluetooth, you are sending data to your colleague or someone else. It's a network. We refer that one as a wireless WPAN. I think it's supposed to be wireless personal area network. Wireless personal area network. I think that's what it means. Then we see how wireless now, where we have something like a router like this. When you have a router, I brought up router before. Yes, when you have a router like this, you now have people, a lot of people that are connected to that router through wireless medium. Such level or such hierarchy, we refer it to as WLAN. You know that this router, we call link 6 router. It has switch, it has three things in common. It has switch, it has what we call access point. Access point is what gives these people Wi-Fi, as we call it. And it also have router. So it has three, is three in one. This particular router, I think is the name of this router is Links Link 6 router. Most of the Cisco routers are purely routing and switch. They don't have APs, but this one have AP. So this kind of network is referred to as WLAN. You know, LAN is uh, local area network. When it is wireless, when it's being set up with wireless, it is called WLAN. So that is the next level for that. I'll come back to what I was talking about. Generally, this one, this antenna, Omnitel is all round antenna. These are different lights, power lights, connectivity lights, and all of that. That's when you see the router. I'll talk about this thing later on. Then I've talked about YPL. Now, these are hierarchies of wireless network. We have the second one. Then this one's supposed to be worldwide, world wireless network. That's what it's supposed to be. That's when you are involving GSM, CDMA, and
Is it worldwide wireless wide area network?
wireless world wireless area network. It's supposed to be something like that.
I was thinking it's wireless wide area network.
Wireless.
Wide area network.
I'm talking about hierarchies of wireless network. We have WPAN. It's supposed to be, this P is personal, wireless personal area network. This is wireless LAN, wireless local area network. This is okay, this is WAN. It's wireless WAN. Yes, it is wireless wide area network. Yes, you are right. Wireless wide area network. Now, it comprises GSM, GPRS, and CDMA. You know the difference between GSM and CDMA. GSM is just GSM, Global System of Mobile Network. Every country in the world, they all have their respective frequencies. When GSM came to the world gave every country their own. Nigeria received their own. Nigeria received their own for a very long time. But the time we started implementing our own it was 2000 and when GSM, we decided to start implementing it was 2002. Whereas other African countries have already gone very far, even South Africa itself, to the extent that South Africa has to come and help us when we wanted to start using the GSM. Now, when we decided to use our GSM, we created different channels, 5 channels for our GSM. From the frequency that we received, we have 5 of them. We sold one to MTN, one channel or one frequency to MTN. I don't want to follow history. We sold to Glo. We sold to 9 Mobile. We sold to Airtel. We sold to Airtel. We now kept one, as we call it, Entel. So these are the GSM frequencies or channels we use.
What about
what?
What about all those networks that we had? What about now?
About what?
I remember that time we had Vista phone.
Yeah, this one is GSM.
Their names, but there were.
No, this one is GSM. We also have CDMA. We have CDMA, as in this. CDMA is it means co-division.
Okay, CDMA.
Now, GSM and CDMA, they use SIM card. They use SIM card. Just as Vodacom now. Vodacom. If you hear about Vodacom, they use SIM card. Vodacom in Nigeria. Which other one again? We have SpectraNet. We have SpectraNet. SpectraNet.
Mm-hmm.
And many other ones. Now, these people, when they give you their modem, they can only do data. They can only do data, like browsing. But GSM is for voice. Is for voice. Although GSM Nigeria, they join and be doing data as well because of phone. People use phone to browse, so they join this one into their own services. But normally, it's supposed to be only voice, while CDMA is supposed to be data. You know, these people you can never use these people's SIM to make call because they don't have the
Oh, now you can use
license channel.
net call.
Huh?
You can use Smile to net call.
Can use
You can
which
net
one?
call now with Smile.
Yes,
Smile,
Skype.
Smile, net call.
If you are using application, just as we are using, I'm on my system, I'm using Zoom. But I mean, like
What
putting
application
the
I like?
SIM on a phone. You can't use their SIM card
Yes,
and
yes,
put
you
it on.
can.
Are you sure?
I've used Smile, like this. Yes.
Smile.
I think now you now have voice over LTE.
Are you
But your
serious?
phone must be voice and you must use voice enabled phone before you can be able to make call with them.
As in your SIM card, you put it on your phone and use it to make calls. Call someone.
All phones, not all phones, not all phones.
Okay.
The
I'm
phone
saying
can
I'm
phone.
saying still the same type of phone.
Yeah.
I don't understand the technology, Sha,
No,
but
it must be a 4G phone. It must be a 4G phone. A 4G that has both.
and you call someone's number.
Yes, you call someone, somebody, the person will take.
Are you serious?
Voice
Wow.
over phones, yeah.
That's technology. Me, I'm not hearing this one for the first time. Okay. So that's that anyway. So that's for Y1. And they have, although this speed, we've outpassed the speed. We can go more than this. Even now we're getting 20 Mbps with even GSM.
Because you're
Technology have improved because of
4G.
you are 4G, even entering 5G safe. So as I said before, this material is 2007. Was done 2007. That was when I did my CCNA. That's the material that I used. So it's been a long time, sure. So the now have you understanding of how networks look like and all of that. I need to bring up this guy. Now, when you set up a network, access points, these are the people that are browsing and all of that. I have another network, people are browsing. You know that this any access point that you are buying has a range you can cover. Some people cover 150 meters, some 200, some 250, depending on the standard and all of that. When I mean 250 meters, I mean radius, as in how far from here it can get to, just as I said before, when you shout. So now, if you can end here, that means you need to put another one for these people soon. Now, when you are using only one AP, that network is referred to as BSS. Please, I need to check the full meaning of it. I think basic service set. Basic service set. Now, if you need to extend, you need to get another AP. And when you are extending, try as much as you can to make the two overlap by 10%. Why it's necessary is that if they overlap by 10%, it means that if someone here is moving to this place, the person can easily move. But if they don't overlap, if someone have an IP address here, someone can have IP address of something like .1 here, for instance, or .11. Let me not use one. And this guy gave someone .11. and this one gets someone .11. And this guy is moving, maybe in another department. Maybe here is sales department, here is production department. This is production department, this is sales department. Someone is moving from sales department, having IP address is 11, and moving to production 11, department. Whereas this guy has given someone 11. This guy will not enter with 11 here. There will be IP address conflict. So to avoid such things, try and see how you can overlap with 10% so that if this guy gives 11, this guy will recognize that 11 have been given. So it will work with other numbers. And when you have overlap like this, it is now called ESS, extended. When we have BSS, more than one BSS combined together is referred to as ESS, extended service set. Then, I don't think I'll come back to this again. I don't think I'll come back to this again. I don't think I'll come back to this again. But you need to read the updates. So, but okay, we have what we call wireless standard. In wireless LAN standard, it is IEEE, IEEE. These are IEEE 802 802.11. So the standard for rules written down for wireless technology is in this standard. And in standard, we have other sections, IEEE 11A, B, G, and all of that. I expect you to go and read up this thing, their characteristics and all of that. Just check this. Go to internet and check IEEE wireless standard. They are more than this. I said this material was made 2007. So as of 2007, this is standard, although it doesn't change, except maybe they do some modification. The frequency, if any standard is using this, is this. If it is 11A, this is what it's using. See the data speed. See the maximum range you can cover. So this one can cover 100, this one can cover 100, but the speed here increases. This one can cover this range. See the speed. You can use both frequencies. We have other ones. You have 11A, AN, we have A, C, we have A, X, and there are many more. You have A, D, there are many more. So you need to know their frequencies, data rates, maximum range, and all their characteristics, and their compatibility too. Like here, you see that G is compatible with 11B, but not A. Okay, A is compatible with B and G, but N does not support A. Now, why I'm saying this is that if you are buying an access point, you see all those things that people mount on top of the ceiling or in their houses for some people to connect to network. When you are buying such thing, they always have standards they are made up of. If it's made up of AC, you need to be sure, or you need to go and explore or confirm the standards that users are using. You check their laptops, their phones, what standards are they made up of? Like my laptop, if I want to check the standard, my laptop is using, I can come here, network places. I hope this is not going to take my time. But it's just something around. Sorry, my laptop is one old laptop, very old one. So go to this place. I need to change. Upgrade laptop. See us very slow. I wonder why it's not giving me. Normally, I'm supposed to go to network. Okay, wireless. You know, we are doing wireless. You found out that the standard is hitting 802. Can you see it?
Yes, I
BGN.
can see it.
BGN. Maybe you can go to properties more to check where, but I know it's somewhere around this place. So let me not go into this so I will not waste our time. So when I buy an access point that is made up of AC, maybe because it can go very far, maybe it can go 500. I'd be like, wow, if I drop this one, someone that is in admin very far will catch it. Not that I'll be bothering to buy multiple APs, access points. I buy this one and put and overlap, buy and put. I'll just buy one, can go very far. Now, it's not about going very far or giving you what you want or the speed. Maybe the speed might be even be 1,000. I'm just saying, no, I don't know. Maybe 1,000 so that everything will be run very fast. I need to go and be sure that the users have compatibility with this guy because there are some users that are able, will be able to connect to AC. Maybe someone, if you check some phones, there are some phones, old phones that cannot connect to your Wi-Fi. Like when you create hotspot, there's some phone that cannot connect. Some old phones. Have you experienced that before? Hello?
Of course.
So sometimes it
I
has to
have.
be this technology. Maybe the phone is made up of 11A, and the new phone they're using is using AX. It might not be able to be. It might not be compatible. Even N is not even compatible with A. So if your phone is using N, another phone that is using A cannot connect to it. So it's very important to know about it. So when you are buying as a network administrator, you check, be sure that you have compatibility issues and more too. So that's that for that. Then access point, you know what access point is. Now, it still has to do with not just your LAN. When you can still bring in wireless when you are dealing with point to point. Like you see all those radios you see on the mask, they are pointing somewhere. Maybe they are pointing on another location. So they are radios. You can see call them bridges. Maybe you are pointing from uh, VI, VI to Lake, VI to Lekki. You don't want to start laying cables. You don't want to start laying cables. You can just use a radio, raise it up, get a line of sight, get your Lekki. So office in VI will now be communicating with office in Lekki. Someone can stay in VI here and print a document inside printer in Lekki. Or there'll be a server in Lekki, maybe a server in Lekki. People in VI will be have access to it. And all that, you just stay as though they are on the same, they are being connected with uh, what do you call it? Cable. So you call them radio. Is in market. If you just go to a vendor shop, you ask them, you want to radio point to point. You get all those radio you see on the mask. They are all those things you see they are radio, but we now have antennas. Some are like this, some are like this. These are antennas, actually. Some radios are like this. These ones go very far because of the antenna. I call this one dish. They travel farther. Why this one does not go too far like that? And these ones are 90 degrees. Of course, you know that is focused. While this one sometimes can be 180, sometimes they can be 270 degrees. So the energy is not channeled as this one. So sometimes you use this one when you have someone here, you have someone here, you can even have someone here. They can all connect. So maybe someone is Oshodi. This one is Oshodi. For instance, if this is Oshodi, this one is say VI. Then this one is Sululele. Sorry. This radio does not really go that far. If you're using this kind of antenna, try and use it. My candid advice: try and use it within radius of one kilometers to stay from issues. But I'm not saying, just giving you instances. You don't need to go that far, so sure, because it doesn't travel too far. Most of them go maximum of 5 kilometers. Most of these radios go 5 kilometers. But this one, I think 3 itself, not even 5. But this one can go up to 5 plus. 5 plus. 5 kilometer plus. So when you are looking for to try get contact something very far, go for radios like this with this kind of antenna. These ones you can just use it within the same environment or not too far. Because this particular one, if you're connecting to 3 things, it might use only one. If you're using the one that is 270 degrees, you can use one to connect all these 3. But if you're using this particular one, you have to buy one to this, another one to that, another one to that, another one to that. So if you're using this particular one to do this job, this one we are going to buy how many? 4. But if you're using this particular one, you need to buy 8. In this case, you use 8. So you should know where to use what and where not to use that. So I think I'll done here. I've done here. I'm done here. I don't think I'll come back to anything here. I need to check more things about wireless. Although these are the things that you consider when you are planning your wireless network. How many users, necessity of coverage. I think I said something about that. Your budget, the cost, and the standards too. And a lot of things. When you get to material, read up these things. Security-wise, consider your security, whether it's okay for you to, use it to do security. If you can serve your security policies and all of that, and the area coverage and the rest of it. I think I still need some things. There's some things that I need to talk about still. Benefits, I think wireless security. I don't know whether it's here. Oh shit. Okay, maybe I will use this one to talk about that. So when you are setting up your wire, can you hear me? Hello?
Yes.
Okay. Now, when you're setting up your wireless, when you're configuring it, maybe in our next class, we'll configure a wireless. I'll show you how to configure wireless. But before that, I want you to download, because you are learning this thing online, download a software called Packet Tracer. It's free. Go online,
Packet
download.
Tracer.
Yeah, do you have it?
No.
Packet Tracer. Download this software so that, because I'll be giving you assignment, I'll be teaching, I'll give you assignment. You'll be doing it inside that Packet Tracer. Because this one, we are not physically have access to routers and switches. If it's something that we have access to it, you can be doing it in real life. But this one, since we are doing it remotely, you can see we'll be doing the same thing. See the way Packet Tracer looks like. I'll open one, this particular one. I'll open and show you. Then, when you're configuring your access points, you need to consider SSID. SSID, what's the meaning of SSID? Forgotten SSID, you can check that on the internet. SSID is the name of your network. Just as when you are creating your hotspot, you create your hotspot as maybe Cisco or whatever name you care about. That name is the SSID. is the SSID. Now we have what we call encryption pattern. Please, can you give me some time? We have, okay, that's packet tracer. Hold on.
I did. Service set identifier.
Sorry, you said something.
Service set identifier.
Okay, service set identifier. Yeah, yeah. Service set identifier. Okay, that's that. Me personally, I don't really have what do you call it? I'm not that used to knowing the full meaning of acronyms. I already know what they do, and I'm okay with that. Of course, thank God that we have internet. If you need, someone needs to get information about more other things, fine. This packet tracer used to have issues when you want to connect online. Well, if you're online, but if I'm not online, it opens on its own. I hope it will open. Okay, look at it here. So wireless device is here like that. Why I can configure this router, wireless router. If I want to configure it, I will do that in next class. You go to GUI, see where you configure the same way you open it in real life. All the configurations are done and all of that. So when you finish configuring it, you bring uh, host. When you bring host, I didn't configure it anyway, but when you bring host, I'll tell you what I'm doing later on. When you bring hosts, after you finish configuring everything, it will connect. Like this one. I didn't configure anything. I left it on on default. So, but when you finish configuring, I didn't configure anything though, as I said, but just to show you highlights on how. So when you finish, you just connect, but you still need to configure some things. So your configuration is done here. Wireless security. I think maybe I'll use this one to explain it. In wireless, we have authentication methods. See the SSID. See where you put it. Whatever thing you care about. If you want to put Cisco as SSID, you put it. Channel. You can select any particular channel. Now, in channeling, it's very important, especially when you have another access point. Make sure that they are on different channels to avoid interference. And it's very important if one is on channel one, this is on channel one. See the frequency on channel one. The next one supposed to be on channel 6. Do you hear what I just said?
Yes.
Yeah. Always give difference gap of 6 width. As you know, 6 difference. How do I put it? If you are connected on channel 1, make sure that the next one is on channel 6. I can't explain why it is like that. It's going to take us a lot of time to do that. So always give space for 5 more to avoid interference. So then security. I'm not talking about so many things here. Now, in security, we have authentication methods. Sorry, these are encryption pattern, wireless security protocols. These are wireless security protocols you can use, either WEP or WPA. As I said before, their meaning, means wired equivalency protocol, while this one means Wi-Fi protected access. So these are two uh, wireless security protocols you can use. I don't advise anybody to use this. This web, this is old technology. Why it's old is that some hackers can snipe through your password and can hack into your web wireless if you're using this one. If you're using this particular security protocol, it can easily be hacked. But these ones are more secure. See, you use the latest version, possibly version 2 of this WPA. Now, if you're using let me use person now. If you're using this, you have another one we call encryption. Encryption you can use either this or this. AES is more secured than this. So most times in security matters, always go for something that is stronger. AES is stronger than this in encryption. And we have authentication methods.
Okay.
You put your password. This is the password that you now put, whatever. So that if someone gets your Wi-Fi, you now ask the person password. Everything is still under, I think it's supposed to be under this wireless settings. You can go to security. Okay, this is on security. You're selecting that and all of that. Now, if you're using this, that means you are making use of Radius server. I'll talk about Radius server later on. Radius server gives your network more security. Gives your this more security in such a way that if you connect this guy to internet, I don't know how to get these things now. Where can I get modem? Modem. Oh, more. Where can I get? No. Shit. Oh.
I want to ask you a question.
Sorry? You said?
This packet tracer, can you also use can you use the packet tracer to simulate wired and doing wireless version?
Can you use to do what?
The packet tracer is it only wireless?
No, every kind of configuration. We have. Well, I just selected wireless. C router. You can use the you can see
wireless.
Yeah. C switch. C systems. C server. You can configure things here. You see phone. You can configure phones. Even tablets, smartphones. You can configure these things. But we'll still get to this place. I'm just trying to Sorry?
After connecting it,
after connecting it. No, just for you to here it's for lab, it's for training. But whatever thing that you do here will work in real life. Maybe now I can possibly want to set up a network for a client. And I picture out how I'm going to do it. I can do it here. I'm going to show the client. I can actually set up the network, everything here. I show the client. Oh, see the way it's going to be like. You can drag and drop, connect systems, give it a name, give it in group. Like maybe I can call this place. I can select this, fill color, select color I want to use. Yeah. So I can just select this color. I can come here and say, these people are sales. I'll select another color. I can go after that. I'll just go and give it to client. Maybe client wants to know how am I going to do my network. Maybe here is my another department. I put a name, type a name and all of that. You can do anything here. When you finish, it helps. I've done a proposal using this before. The person will see everything. Okay, this is where it's supposed to be. Okay, connect this. If person wants to make correction, you make correction here on the screen and all of that. But it's majorly for lab, for practice. Whatever thing you do here, you can do it in real life. If you work here, you go to work in real life. So the basic thing you need to know about in wireless, and I expect you to go and read up, is encryption. I said under encryption, we have AES and TKIP. Sure, that was what we saw.
TKIP.
Now, that's for encryption. We have wireless security protocols, web and WPA. We now have authentication methods. Authentication methods are PSK and EAP. PSK, supposed to have it. This is encryption. We have PSK and EAP. It might be when you are using this. Use personal. Okay, now we have authentication method. How is one authenticated? If you are using password, like this paraphrase, it's asking me which password do you want to use. If I'm using this is called PSK, pre-shared key, pre-shared key. That means when you are putting password here, do you understand? Hello?
Yes.
Yeah. So when you have password here,
I can hear you.
okay. When you have password, when you have this kind of setting, I have password here. My authentication method is PSK. But if I'm using a radius, server, that authentication method is referred to as EAP, Extensible Authentication Protocol. When I'm not using radius server, the authentication method is PSK, that is password alone. But when it involves radius, if I'm using radius server, my authentication method is Extensible Authentication Protocol. EAP is when is a protocol is the authentication method when you are using a radius server. While PSK is pre-shared key when you just put only password I showed you on the screen. This one is on the screen now is EAP authentication method. That's extensible authentication protocol. It works with the radius server. So 3 things you're supposed to know here: authentication methods, EAP and PSK. Encryption, we have AES and TK-IP. Then the wireless security protocols, WEP and WPA. I know your SSID. That's just that. Anybody can configure wireless just for you to have an ID. So you just need to go to your materials and read up all these things. So all these things are maybe explained in a elaborate way in your materials. Of course, we're going to give you your material. So I will call it a day on basic component, basic computer components. We are talking about host, peripheral, devices, and media. So in our next class, we continue with frame. I made mention of frame. We continue with frame and more things about more things about ARP tables, routing tables, and many more. So we're taking it bit by bit. So for today, we're going to call it a day, except you have questions. You have questions?
Just I need to digest. You actually said a lot of things today.
He said,
I said we said a lot of things today. I believe that what you did today was actually 3 days lecture.
okay.
Or
All right.
three yeah.
No, what I did today is a one class. So I teach.
Wow, I was thinking it's just
basic computer component is a class. That was why I wanted to finish it. It's a class. And we are meant to have, but this one we are running wireless. We are running remotely. I don't know how many.
I will have to be. I'll be Lagos this month now.
Okay,
We'll
come back.
Lagos this month.
Okay, fine.
Yeah.
All right. So that was that for that. So one more thing is in more security, adding more securities in your wireless. You disable brokers of SSID. You don't want people to search and see your name of your network. You can disable it. You change the default values, your username and password of your wireless and all of that. You encrypt it. I talk about that. MAC address filtering. You filter MAC address in such a way that you only put MAC address of your host, maybe your phone, you check the MAC address or system, check MAC address. I will talk about that in our next class, possibly. You put the MAC address. So it's only the MAC address that are registered here. we're able to have access to this
can
place.
see.
Yes, even if you know the
Oh, wow.
password, even if you know the password of my wireless, if you are not registered here, if your phone is not registered here, you can't connect. You still have traffic filtering. Which site should you go to and which site should you not go to? Authentication, I'm talking about that authentication methods. If you want to use PSK or you want to use EAP server, radio server, and all of that. So we call it a day for today. So in the next class,
Right.
sorry,
When next are we having class? When next are
if you
we?
want us to have this night, because me, if I'm not busy, I am not busy. If I'm busy, I will be very busy, even in the night. So it is not the only thing that I do. I do a lot of things. I program. I even have a project that a client gave me. Two projects, not just one. So I'm running a program. I'm doing this. So I have a lot of things that I do.
Okay, that's what we learned today. Um,
No,
what are you going to upload the recording?
when are we?
What are you going to upload the recording with you?
What I will do, I will just upload it maybe on a YouTube and give you the link. You can go there and download. But I might need to edit it to remove some things, remove some videos. Yeah. All right. In absence of any questions,
I will have to go through what the talk today, and then maybe tomorrow again. Instead of another lecture tomorrow.
okay.
I mean tomorrow in the evening.
Okay.
Friday in the evening.
And you're not on WhatsApp.
I don't. I'm on WhatsApp now. I'm on WhatsApp.
Give me your WhatsApp number. I don't like calling because calling, I spend a lot of money calling. I better chat you up. Is this number on WhatsApp?
Yes, I'll send you.
Eh?
This number is also on WhatsApp.
I will be using WhatsApp instead of calling. Yeah. Here I can drop a software. I'll drop the softwares as in some materials you can be reading. I'll drop it on WhatsApp. Because there should be a way of dropping it here, but I'll take time to see. No, I told you before that this is my first time of doing this. I've not done Zoom. I've not done
You
Zoom.
can send it to
Hmm?
ebooks.
Yes, ebooks. Yeah, yeah. Ebooks. I will send it to you through WhatsApp.
Yeah. Then
All
when I
right.
come to Lagos, my laptop, and then I have to install
Other materials. Yeah. All right. Now, see ya. Okay.